Welcome. This is exploring the area and circumference of circles. So, this will talk about ancient ancient geometry to modern engineering, key formulas, historical context, and practical appliances. Oh yes, today is December 28th, 2025. So, Alex is my name. Yeah, I'm the presenter of this one. Okay. Okay. So we're going to be talking about key circle terms: center, radius, and diameter. It also talks about clear definitions and simple relationships for circle geometry. So, our first vocabulary term is center. A center is a fixed point equidistant from all points on a circle. It defines the circle's position. So, a second term is radius, which is labeled R. It's the distance from center to the circle boundary. It's half the distance across the circle. A third term is diameter, labeled D. The diameter is the distance across the circle throughout the center, and the diameter is equal to 2 times the radius. It's the full width passing through center. A fourth term is arc. An arc is a portion of the circle boundary. It's a curved segment between 2 points. So, our last vocabulary term, I think, is chord. A chord is a straight line connecting 2 points on a circle, so it may or may not pass through center. Okay, so here's the evolution of pi. So it's key historical approximations and milestones. So, back in 1900 BC, there's a Babylonian approximation. Pi is valued as 3.125, or 3 and 1/8. Now, 250 years later, in 1650 BC, there's the Egyptian. And now its approximation was about 3.1605. Now in ancient Greece, the Archimedes bounds. So pi bounded between 3 and 1/7 and 3/10^71 using polygons. Technically, I do not know why we're using polygons. And 319 years ago, close to 320 years ago, the symbol of pi was introduced. So William Jones coined pi. Earlier popularized it in 1737. That's crazy, isn't it? So I'm guessing pi was 3.14159 back in 1737 when George Washington, the first president of the United States, was 5. Crazy. So now the circumference, distance around a circle. So use radius or diameter to calculate the perimeter. So its definition. The circumference is a distance around a circle. So the length of a circle boundary measured in linear units. So the formula then was circumference equals 2 times pi times the radius, or circumference equals pi times diameter. Hold on just a sec. So, now that the circumference is equal to 2 times pi times the radius, or the circumference is equal to pi times diameter. So use radius or diameter d. Pi is pi. 3.14159. You don't have to choose both, but I'm suggesting you to choose one method. So the units, linear units such as centimeters or inches. Centimeters and inches are the two key measurements that I always measure my stuff. So it's the result expressed in same linear unit as R or D. So here's an example. The radius equals 5 centimeters. So if we take one of them, so circumference is equal to 2 times pi times 5. So now it's 6.28 times 5. 6.28 times 5 is about 331.4159. Sorry if I got that mixed up again. So if we take the circumference to becoming pi times the diameter, that still works. So the diameter is 10, so 10 pi. And that's 31.4159. Approximately t equal to. So the circumference drives linear travel. So how rotation converts circle geometry into distance. So here are some real applications. So number one is a Ferris wheel. It's a distance per rotation. So radius 10 meters gives circumference 2 pi times 10. So the circumference then is approximately equal to 62.832 meters traveled along the rim. So then you need to use circumference to convert rotations in linear distance. So, number two is a car tire, travel per rotation. So the circumference equals distance per full rotation. So small diameter change travel proportionally. So now it's important for odometer accuracy and gearing calculations. Likewise used in a vehicle. Semis, cars, trucks, walking vehicles, delivery vans, Ferraris, Lamborghinis, all of that stuff. And now here's a key insight, which is number 3. Circumference determines linear travel per rotation. And area determines enclosed space or material used. So, here's the area of a circle. Space inside a circle. So compute area with the formula A equals pi. Okay, so area equals pi r squared. So, the definition. Area is a space enclosed by a circle boundary. Its amount of two-dimensional space inside the circle. So, the formula is A equals pi r squared when r is the radius. So, use radius to compute area with pi. Okay. So the units to identify the area of a circle is square units, which is centimeters squared, inches squared, so area measured in units squared. So why on earth do we need to measure a circle even though that the units are, it was called area, the area equals whatever, the area formula is centimeters squared. So if I measure my clock, then why would it be like 31.4159 inches squared? So write that down in the comments if you know why. So, for example, for radius equals 5, area is equal to 7, approximately equal to 78.5398 centimeters squared. So area is pi times 5 squared, okay, radius squared. So equals pi 25 pi is approximately equal to 78.5398 centimeters squared. So I'm still a little bit confused on some of this. So, visual proof. I'm wrapping a circle into a triangle. Now, this is crazy. So, slice into rings. So, divide a circle into many thin concentric rings that capture all area. That's number 1. Number 2, array rings side by side. So, cut and arrange rings end to end to form a shape approximating a triangle. So, now it's time for number 3. It's the triangle base. So, total base equals the circle circumference. 2 pi squared. 2 pi radius. Number 4, you need to focus on the triangle height. So, height equals the circle radius, r. Number 5, we need to compute the area. So, triangle area is equal to half times base times height equals half times 2 pi times radius. Like, half times 2 pi times 2 radius is approximately equal to pi r squared. Now, this is crazy. So crazy to find out. They turn a circle into a triangle. Pizza principle. Diameter doubles, area quadruples. Oh no. So, why a 16-inch pizza has 4 times the area of an 8-inch pizza? So, 8-inch pizza, the radius is 4 inches. So, area equals pi times 4 squared equals 50.2655 inches squared. And now the circumference is 2 times pi times 4 is approximately equal to 25.1327 inches versus the 16-inch pizza with a radius of 8. The area of pi times 8 squared equals 201.0619 inches squared. The circumference is then 2 pi times 8 equals 50.2655. So can you get the difference between the circumference of being 25.1327 and then 16-inch with circumference of 50.2655? So speaking of which, we could divide it by 2. Okay, so the 16-inch piece has more circumference than the 8-inch, which means the area is 4 times larger than the 8-inch. Okay, so we're going to avoid common circle mistakes, radius, units of pi. Quick checks to keep area and circumference accurate. So, some people are confused on radius and diameter. So using diameter and area equals pi r squared gives pi times d squared. Now that's incorrect. Its area equals pi times radius squared, not pi times diameter squared. So, now some people forget that they are mixing units for measures. So circumference uses linear units, area uses square units. So, one thought. I have one thought. So, linear units are not what's needed for circles, according to me, but if it's according to you, write it down in the comments. Speaking of that, the circumference is just units. Not units squared, not units cubed, not units quadrupled, none of that. So people are forgetting around pi on time, but they're accidentally rounding pi too early. So using 3.14 prematurely creates compound errors in multi-step work. So best practices. Confirm radius for diameter. Keep pi for work and it labels Venus clearly. That is how we should be doing it. Number 4. 4 is correct. 3 is long. 2 is long. 1 is long. 4 is correct. So here are the final takeaways. So core circle formula. So key formulas, visual proof, and practice hack. So circumference is equal to 2 pi radius. Area equals pi r squared. Pi equals 3. Is approximately equal to 3.14159. Doubling radius doubles circumference, but quadruples area. So try practice problems with radius equals 3 and radius equals 7 centimeters. Compare areas when diameter is doubled. So, I'll make another video with this on Friday, the 2nd. So, just remember, take your time and avoid these mistakes. Okay. this is it. Thank you for watching this video. Make sure you practice those problems. The practice is radius equals 3 and radius equals 7. Make sure you like and subscribe.